Right, so yeah, where are we? Let us start with your guys' projects. Everyone happy to show what they did on the big screen? Right, so where are we? So whose was connecting circles?
Mine.
Yours? All right. So this will run. That is cool. So is it going from the mouse? Oh yeah, mouse position.
Yeah.
Oh, very nice. So what is it? Does it just go out to a certain size and then start winding itself back in, does it?
Yeah.
Cool.
Changes color as well.
Yeah.
So, yeah, there was an existing one. I just made changes to the existing one, changed some of the thickness of the line and also the position of the mouse to make it so the original one was sort of randomly generating the line.
Yep. How did you find programming processing?
I guess it's Java. I was used to Java, so the only thing was just getting around the like all the physics and all the animation and stuff.
Yep.
Yeah.
So you'd be happy to keep using processing?
Yeah.
Cool. I mean, you don't have to, but and either tomorrow or next week, depending on how we go today, we'll have a look at Open Frameworks as well, which is based on C, so it's arguably a little bit more powerful, but yeah. Right. Next one is Murray's. Hopefully this one, I'll put everything in the right folder, so it looks like it.
Slide it back. That's all it does.
Mm-hmm.
The story behind that one is a request from a business down south from peak accommodation in Wanaka, which I did a lot of virtual tours for, want a slider image down. You know the slider images work on a website?
Yeah.
And they want to do that with virtual tours.
Mm-hmm.
I have not been able to find anything available. And I was starting to play with stuff. Got that working and I thought that'll do it.
Yeah.
To get you to a stage where I'm trying to get it running so it runs on a website.
Mm-hmm. Yep. So you've found it easy enough to write and stuff?
That was easy. I just got found an existing example
mm-hmm.
and modified the code to line in there.
Sweet.
Uploaded the image, put the text in, you know what I mean?
Cool. Well, let us know how it goes with getting it online as well. I know.
If anyone wants to help, they're welcome to. It's actually a paying job.
Yeah. Well, I know, Jonathan, you were saying that there was something about the latest Java update blocks processing sketches.
Yeah, on the website, so you have to download.
Although that was on the Open Processing website as well, wasn't it?
Yeah, it's something to do with the Java long time because they're hosting files on multiple servers because the website's hosted.
Okay, right.
Because the computer could be attacked. So it blocks it, even though you change the security settings.
Right.
And about it.
So it might not actually be a problem with running it on the web. You just have to make sure it's on the same server as the web page being hosted or something.
Yeah, because some of them will work.
Yeah, I had a look after you sent me that email, and yeah. So it might still be fine. As far as getting it running online, I haven't actually done it myself, so I'm not sure. But
I was serious when I say that's a paying job because it's for Hugh Van Hale. He's a marketing manager for Infinity Wanaka.
Mm-hmm.
You know, they own Pegasus.
Yep.
They still own half of Wanaka.
But yeah, so you're happy with the code? Because I mean, I suppose yours.
What it does.
Yeah, and you could explain it line by line.
I think so.
Okay, no, that's all right. I mean, I'm not going to make you explain it line by line. I mean, I'm more just want to make sure that you guys are sort of, happy and you're sort of following along. Because if there's any more detail we need to go into, I'm happy to do that as well.
Yeah. Well, if you've got time, I might go through it line by line.
Yep. Okay, we'll do that. How about we do that maybe after class? Just
Yeah, that's right.
right. So you've got 2. So this is the first one.
This is basis of Kristoff sum. If you left click, it will generate these weird eyeball. No.
All right. Well, you get an F.
Oh, cheers.
No.
No, it's doing a loop, so it has to draw multiple loops on top of each other.
Right.
So that's what's probably taking so long. If you want to shorten it down, you could probably, instead of 2,500, put enough
Oops, wrong button.
Just change it to like 100 or something.
Yeah, this isn't the.
Weird little ball, I think.
It's not the fastest machine.
Yeah,
Oh, there you go.
When you click it, changes it. Basically, it's just a grid of those things.
Mm-hmm.
And then
Just tempt fate and try jacking it up. Oh, there you go.
so that was supposed to be based. Actually, this was completely by accident. I was trying to do something for your assignment as well as Christoph's, trying to merge two things together with the shape changing thing, and I ended up getting this weird thing happening in the corner. So I just thought it was good.
Fair enough. And should we have a look at your spiderweb one as well?
I was trying to make spiderweb. So the same deal again, you just click and it will generate it, but it's only half.
Actually, kind of looks more like that scene in Star Wars where he's like flying through the Death Star to try and drop the torpedoes in. You just need to put some grey colours in and a couple of TIE fighters and stuff. What's that?
We're going to do another meeting with the virtual actors, so.
Yeah, let's not talk about that. And last one must be Robin's. So left click, right click, middle click. Well, that's going to be difficult because I only have one button on here.
Yeah, pass wheel.
Oh, yeah. I think.
Maybe not.
Hold on, there's a keyboard. I am strapped in. Is this USB or PS2? The things I do for you guys, I don't know. Hopefully that'll be coming really. Okay, let's try that again. So we've got left click, right click, middle click.
Oh, I've had that before, that's it.
Ah, it's running in presentation. There we go. So left click changes the number of things on it, is it?
Yep.
Yep. And right click reduce or decreases them. Mouse wheel is. I see changes the. I guess the angle between the inny bits and the outy bits, for lack of a better word. And what was the last one? Middle click.
Oh yeah, that just moves the shape, but that's sort of random.
Ah, okay, I see. So it just sets it. Oh, very cool. Oh, good job, guys. So yeah, everyone's fairly happy and competent with a little bit of graphical processing stuff now.
Just have to not be late.
Yeah, it's the hardest part of any job, isn't it? Right. Yeah, and I also apologise that I gave you homework when Mark had also given you homework. I didn't realise they'd given you some, but to be honest, I still would have given it to you anyway because you need to learn process. Well, yeah, you really need. We want you to learn at least one of processing open frameworks to be familiar with. Right. So I had a look at. I could only actually remember one of the things I screwed up last week.
That doesn't work. You have to use POD.
That's correct. Yep. So that was, I incorrectly said that's to the power of. It is in some languages. I think maybe Visual Basic. I tried it in C this morning. Thought it did work in C, but apparently not. But yeah, that's actually a bitwise exclusive OR operator. So 2 exclusive OR 5 is 7, but 2 to the power of 5 is 25. So 2 is 0, 0, 1, 0 in binary. 5 is 0, 1, 0, 1 in binary. So you exclusive OR. So basically, when either of them is true but not both, so this is 1, this is 1, this is 1, and 1, 1, 1 is 7. So, oops, sorry. So yeah, as Jonathan said, if you want to do power, it's actually power base exponential, the base exponent. I actually went back and removed that from last week's slides because it doesn't really make sense. What's that? Yeah, no, we looked at them.
Yeah, we did. We looked at September and
Yeah, if you have a look at when we get, oh no, because the video crashed. The slides are online anyway. Yeah, But yeah, so plus minus divide times modulo. Power is now pow, and obviously the opposite of that is square root, which is SQRT, or you can power to a, like, power 2 or 5 to the power of 2 is the same as power of 5, or 25 to 0.5. So yeah, so on and so forth. Does anyone remember the other mistakes I made? There was a couple of things I needed to check. I couldn't remember what they were. Yeah, I have a feeling. I know there was some confusion.
With array and array list.
Yeah, I thought that might have been what it was. So I had a look at that as well. So we looked at. Was it? I know we had. So we had, if we do an int array equals 1, 2, 3, that's fine, and then we can do an array list of strings.
Now if you put the brackets.
Oh yeah, sorry. New array list, and then I think if that works.
String, capital S.
Oh yeah, sorry.
I was going to do a flux. I think you're trying to add flux.
Yeah, so we talked about how you can make, because the difference between one of these arrays here is that that's fixed at compile time. So this array will only ever have 3 items in it. This one allows us to actually add and remove stuff as we go. And then I was saying, you could just use an array list of ints. My int array equals new array list. But when we try and compile that, that will have a moan that it can't do ints. So what we can actually do is we can use integers. So an integer is basically a complex data type wrapped around an int. So essentially inside it just holds an int, but it's a class. If you were to write it out, it would look something like this. Class integer int value. And that's, it offers more function than that. So it allows you to do pretty printing and all that sort of stuff. But this is essentially what an integer is. And then we should be able to do my int array dot add. I think it's append, isn't it? 1 and append.
Yeah, I think so.
One of them I looked at was, yeah, there we go. So yeah, you can now add an int, because integer knows how to, integer will have a constructor which takes an int, it knows how to convert an int into itself. So if you want to do that, there is actually another one I found yesterday. If you look at the, processing array list.
They got that, how they do it in mono, where if you start typing more, put dot and show the list of methods.
Yeah, so that was, remember I said yesterday, and I actually had a look at this. I said, well, not yesterday, sorry, last week I talked about how you can actually write processing in Eclipse. That's the reason why you'd want to do that. So there's no autocomplete in the default processing IDE at this stage, which is a shame. Yeah, so if you want to have a look at Eclipse, there are instructions on how to get it running. I'm not going to bother doing it in class because it can be a bit tedious. But yeah, anyway, so there are actually int list, float lists, and string lists if you want to do just straight into that. So we could actually just do int list my other int array equals new int list my int other int array dot. Now I can't remember one of these. Yeah, so this one was append, just to confuse things. There you go. I don't know why they chose to, in this one add, you can specify where you want to add it into the list. In this one, the add method takes a value and I think a position in the list to add it to. So you have to do, I don't know why they did that. That seems incredibly counterintuitive to me, but we have to play by their rules, unfortunately. So, but you can always do an array list and just pass it in an integer rather than an int and it'll all work fine. So I think from memory that those were the two things I needed to check after last week's class. Does that make sense to everyone? Yep. All right, so continuing processing. Goals, lecture overview, programming processing, interaction. So this is pretty much where we left off from last week. So looking at mouse interaction, so obviously a few of you guys have already done this, so this shouldn't be too surprising. But let's have a little look. So let's just write processing void draw, and we could just do something. I'm not going to draw anything pretty, but we can go print mouse X, mouse Y, and thanks. So yeah, you can see down at the bottom here, it basically is printing the X and Y position of the mouse. So we have these two variables which always have the position of the mouse from in the current frame. We also have these mouse interaction things. We can have void mouse pressed and printing.
I had this weird thing happening last week where when I was trying to change color in draw, it was updating it multiple times.
Yep, so there is a point in this lecture where I will talk about that. I think I looked at it last night anyway. Oops. And void mouse dragged. Mouse was dragged. Now it should be fairly obvious what is happening in all of these, but mouse pressed. Okay, I'm going to copy that out because that's coming up too many times. So push the button down, mouse was pressed, let go, mouse was released, click and click down and then drag, mouse was dragged. There is also, sorry, I forgot to add that into the slides, the mouse button. I'm pretty sure that's what it was anyway. Yep. Yep, so it comes up with a weird, oops, I don't know, I hate how they put, every mouse or keyboard, laptop keyboard has all the buttons in different places. Right. That's right. And paste. So we run that now. We say mouse was pressed 37, 37, 37 is left, 39 is right, 3 is middle. Doesn't make a lot of sense, but we can easily just go need to bring my keyboard and just plug it into this. Mouse button equals, I think it's just left. Mouse F, mouse button is right.
Dragon actually speaking weakly.
No idea. I can type pretty fast anyway. So left mouse button was pressed, right mouse button was pressed, middle mouse button was pressed. So yeah, it's got these left and right things which are automatically mapped to it anyway. So if you need to do mouse interaction, you can at any point in time get the current mouse position by mouse X, mouse Y. There's the methods mouse press, mouse release, mouse drag, which are events which fire at certain things. And then we have this nice little piece of code here we can do. So we also have these variables pmouse X and pmouse Y, which are the position of the mouse pointer in the previous frame, which if you're doing drawing functions can be quite useful. So we can go, ooh, and look, I can draw nice pretty patterns. And I should have made that window larger. The reason it's cutting off there is the window's actually only this size, but because Windows requires a minimum of it being the size in order to fit all the enormous buttons in, there is actually nothing here. So if I actually in setup, set size 640, 48, 80, then I can use the whole draw right to the edges of the windows as well. So yeah, it's possibly a little bit over the top, but it's nice that we don't have to store the previous mouse position ourselves because processing makes that available to us. Keyboard interaction. We have this, where are we? Key pressed method, which basically tells us if a key has been pressed since we last checked. and the key value, which stores the current key value. So we can do this. Oops, I should have put a println in there. So as you were saying before, like the draw method, because the draw method runs pretty much as fast as it can, I push, no matter how fast I tap it, we're going to get like multiple occurrences. So we have here L, 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 L. Like basically, in the time it took me to quickly tap the L key, the draw method ran 4 times. So we end up doing this. So if, say, we don't actually want this to happen, we can just use one of these event handlers.
Yeah, I end up doing that for left mouse click. That's why. Because doing the draw thing is just too hard.
Yeah. So I mean, it depends on what you're wanting to do. If you're doing something you only want to fire once, you should probably do it in its own method. If you're doing something where you want to continuously happen, you can do it in the draw method. So now, if I just comment this out, put something in my eye. You press G, you press V, you press B, you press N. So because this is only firing once per key press, this will only happen once. If I put it in here, it's going to happen every time the draw function runs, which is 4 times faster than I can actually press and release a key. You'll see this follows the standard Windows key repeat stuff. So if I hold down P, you sort of have that 1 second or half a second delay, and then it keeps repeating after that. Yeah. So that is key input. Now let's get into graphical control. So this is where it starts to get a little bit more complicated. So we're going to have a look at a couple of libraries, one in a bit of detail, one in not so much detail. So this one we're going to have a look at is this library Control P5. It's written for processing, obviously. It's a GUI and controller library, and basically provides a whole bunch of things like buttons, sliders, color maps, etc., etc. This mouse has a really sticky wheel. That's quite gross. I'll just go back to using it. Right. Oh god. Yeah. So accordion strips, I don't know what a bang is, a button, canvases are usually just like something you put all your content in, so you can have multiple canvases, charts, checkboxes, color pickers, drop-down lists, knobs, list buttons, etc., etc., etc. So there's lots of stuff in there. I'm not going to go anywhere near into that much detail, but provides examples. And yeah, I included the reference in here as well because it's standard Java doc reference.
It's all GUI elements.
Yeah, GUI elements and GUI and event-driven stuff. So yeah, there's the Java docs here, which Java docs, when you look at them, are often quite overwhelming. But once you get the hang of them, they're not so bad. So basically, if we wanted to learn how to use a button, we can look in all classes here, or you can look in the package, whatever. Or look, because this isn't too big, look at button. And I've done quite a good job here in that for most of them, they actually include a little example. So we can just copy and paste this straight into our code, and it will do some stuff. Yeah, it's brilliant. So yeah, basically it has some functions about what various things you can do. Turns a button into a switch, use a toggle, so a switch is either on or off a toggle, you push it down. Just set values, set on, set off as pressed, etc., etc., etc. So there's lots of documentation. This is what it looks like. So it's got that kind of futuristic-y, minority report-y sort of interface if you're into that sort of thing. But yeah, so list boxes, multi-level lists, radio buttons, ranges, so you set the minimum and the maximum range, text fields, number boxes, which is just text fields which only take numbers, check boxes, buttons, sliders, knobs, more sliders. Yeah. So let's have a look. So first thing we need to do is jump to the website, which is this one, and hit download, and we click on that and we download this zip file, which I've conveniently prepared earlier. Look at that. So it has some install instructions. which if you try and open them on Windows, because it's in a non-Windows format, will be all on one line. So I'd recommend maybe installing something like Programmer's Notepad, because it's a lot better than regular Notepad. Yeah, it pretty much does the same thing. It has syntax highlighting and all that sort of stuff. And it works quite well at opening ridiculously large documents. So, if we put this in... Do I use the sticky mouse wheel mouse, or do I just try and use the terrible trackpad? Right. So, how to install it? Move folder Control P5 into Processing's library folder and restart processing. And then it explains how and why you might want to do this. But basically, if you remember from last time, and obviously you guys have figured it out because you sent me your things, if we go into your My Documents folder, there'll be a processing thing. And inside the processing thing, there's a libraries folder. And all we have to do is click and drag Control P5 into there, and we are installed. Just that easy. Oh, and we have to restart processing as well. So, that one there.
I have seen people fumble the libraries with Sketch. Does that make sense? Like they'd actually put in the folder, they'll have actually the libraries folder.
Right. Oh, okay, yep. So you provide the sketch with the libraries inside it.
Oh, okay.
No, is that? Yeah, okay, yeah.
So if you put it in the local folder,
yeah, I guess so. I guess that's if you're deploying a sketch with a library that people may perhaps not have. That way you can just provide one folder rather than providing your sketch and then someone else. So I haven't actually tried it myself, but I'd suspect that's what it's for. So now you see, because processing's kind of cool, if we go to Sketch, Import Library, you'll see down here we have contributed, which is all the libraries which didn't come with processing, and there's Control P5. If we also go into our examples, you can basically draw to PDF.
Yeah, I tried it last week. It didn't work.
I tried it last night and it did, but it was pretty boring.
It'll make PDF just 0 kilobytes.
Oh, right. So you need to make sure you close the PDF after you're done. Would have been the mistake, yeah. Anyway, so if we go into the examples, you see there's contributed libraries, Control P5, and it comes with a ton of contributed or examples as well that you can do various stuff. But let's try our own one. So the first thing we're going to need to do is import our library. Pow, that was easy. So everything in Control P5 is created through the Control P5 object. So the first thing we need to do is Control P5, CP5. So this is basically our root object that we're going to create everything off. Void setup, and let's just create a new one. So this is something you haven't seen before. So basically, when we create the Control P5 object, we need to attach it to the program which is running. So we just go new Control P5 this, and that has to be run within the setup function. So we couldn't actually put that out there because until setup runs, there is no this. But yeah, just something you have to remember. Oh, and the other thing you have to do, which I found out the hard way, is you need, if you're using Control P5, even if you're not doing anything in the draw method, you need to include it, or it won't. Well, it'll draw your controls, but they won't do anything, so they won't work. So now if I run that, nothing, because we haven't actually done anything. But you see now I get this little message down here, Control P5, info, comments, questions, blah, blah, blah. Whoop, where are we? So Control P5 offers lots of functions for adding objects. So if we follow this link, this is, oh no, this is the one I want. Is it? Maybe not. Look down here, Control P5. All right, so I didn't update it. So if you go to Control P5 base, you'll see in here, add accordion, add bang, add button, add chart, and there's multiple different ways of adding it. So if you wanted to add an accordion, you could just add it by the name, or you could add it with the X, the Y, and the width of it, and they're all like that. So button, you can add the object, the index, the name, The most easy one for adding a button obviously is just to specify the name, or you could specify the name and the value, the name, the value, the X, the Y, the width, the height, and so on and so forth. It's depreciated now for some reason, but never mind. Yeah, so basically we've created a control P5 object, and then we can just call any of these functions on there, c5.add_button, my button. So we've basically called this function here, add button, with the name of our button, and control P5 basically references everything by name. So you give a button a name, and then when an event fires that the button's been clicked, it will say the button which is being clicked is my button, so that you can identify between which buttons have been clicked. So I click on that now, and I have my button, and I can click on it, and it doesn't do anything because I haven't told it to. Yeah, so add a button, button 1. We'll do another one. Let's do a color picker. Oh, and we can also, like these all return a reference to the object. So we create a button, it returns a reference to the button. So if we wanted to, we could store it like this as well if we want to do any changes. So we could say from here, so if we rerun this now. Yeah. Well, yeah, I guess so. I don't know. So you can see now here that the two things are overlaid. You probably could change the name, but I would recommend against it. You probably just want to give something a name once and just leave it. If you need a button which does other functionality, create a new button to do that. Sorry, something in my eye and it's incredibly itchy. But we will persevere. So yeah. I don't think it's going to come out. I think it's, yeah. That'll be fine. So yeah, you'll see the button here. You can just sort of make it out underneath our color charts. That's not ideal. So what we could do is say col pick 1, and this is where IntelliSense would really come in handy. Color picker. So let's have a look at the color picker. I want to move its position. So we have to look down, and it has a move to method. So it's move to 100, 200. Okay. That's obviously not doing what I thought it was going to do. Move to, oh, I see. So that moves it within a sub-controller group. So there must be one in here for the position. Get width, height, update, move to, set height, set size, must be in here. We can set the width. Let me just skip forward to my next slide because oh, was it? Oh, there was 2. I was looking for that, but I glazed over it. So yeah, set position, X and Y. And I think I've moved it clean off the screen. Let me actually make this a little bit bigger. There we go. Yes, so it's in pixels. So there you go. We can move the thing. So we can basically create a button or a color picker, and then using this reference we can set the position. So we can just call all its methods on it. There is actually, because every method which these functions offer, this is just sort of a little aside for people who are somewhat familiar with programming. Where am I? Where did that one? I don't need that. All of these actually, so if I call set position, it actually returns a reference to col pick. So I could actually do color picker, my col pick again, like that, and that will actually point to the same as this thing here. You might ask, why would you ever want to do that? Why would you want to set the position of something and then get a new reference to it? It's because by doing that, we can actually write something like this. So button 1 equals add button 1, set the position, set the size, and because each of these returns the same thing, we can just string them all together like this. So CP5 add button, set position, set size. So on one line, I can now write this as dot set position. Oh, it's move that back so I can see what I'm doing. Set position 100, 100. What are you doing? Yeah. Okay. And now if I run that, it will do the same thing. So instead of having to write that in 2 lines, and I could keep stringing these. So now if I want to set the width, I could set the width in the same line. It's, okay, for some reason it's only set the width of the bottom one, but I guess that's just how this color picker works. So these are all from 255 pixels wide from 0 to 255, but because we've set the width, it's set this width. But yeah, you know, it's unnecessary because we could do it in one go, but it actually makes the code a lot cleaner, a lot nicer to write. And in fact, when you see the reason I mention this is because if we go back to here and look at our button example code, you see they do it here. CB5, add button, set value, set position, set size. All they've done is just put an enter between all of them so you can see what it does, but it actually makes the code a lot cleaner looking.
Is that valid though?
Yeah. No, so I think Python can be a little bit anal about white space, but certainly Java isn't. Yeah. So in C, it treats white space as if it wasn't there. So this is as valid as having that, is as valid as having that. It's all the same thing.
Color it correctly too.
Sorry?
That was color it correctly.
Yeah, you'll notice that in just about every programming language. That's right. I'm not quite sure what just happened to that code. Awesome. I'll put it in there again. So yeah, this is an example here where I've created some buttons, color A, color B, color C. Oh, there's actually supposed to be some images in here as well, which if I had them, I think you'd see some image buttons in there, but I don't. Actually, I suppose I could quickly cheat.
So a button can take an image, or is it different?
Yeah, so I think they can. Let me just double check. So I'll just create a copy of that. And new data. I think it needs to be, I don't know if it makes a difference, but it should be in lowercase d. And let's just steal Murray's logo because it's the only image I have handy. There you go. So maybe should have made that a wee bit smaller, but yeah, so there's buttons now which are, I think there's supposed to be a, where's these images used? Yeah, so I think the first one is the button unclicked and the second one is the button clicked. I don't know. Let's have a little look-see. Hope you don't mind me messing with your logo, Murray. Save as. That's really useful, isn't it? Ah. A.
If you run the eyeball thing, you can actually press this.
We're almost done here. And let's rotate this one back that way. And rotate this one more. Yeah, if I had a better imaging editing program on here, I'd do something a bit more interesting, but it's okay. Hopefully this will get the point across. Yeah, so actually I might just get rid of one of these so we can actually see a bit better what's going on. And let's set the position a little bit closer. And let's set the size to be a bit bigger. Right, so when it's normal, that is obviously the first image. When we mouse over it, that's the second image, and when we click it, it's the third image. So yeah, you know, you can make your own buttons, which look various ways. Anyway, so yeah, was this the slide we're up to? Yes. So events in color P5, or control P5, sorry, are received by every event which happens is received by the control event function. So let's go back to this example we had.
So is the processor program actually running JavaScript through these modules in the background?
No, so someone else has already written.
And yeah, that's what I'm picking up.
Yeah, so someone's written the control P5 stuff, and then this is basically running the Java code on the Java interpreter.
Yeah.
I don't know why that. Yeah, no, it's quite good. Yeah.
You get a bunch of points. So, as Adrian said last week, there's no point in rewriting everything.
Yeah, I mean, I'm a big fan for whatever. I mean, and especially you're going to find this doing your masters. You don't want it to start. The whole idea of research, you know, the old saying goes, standing on the shoulders of giants. So if somebody's done all this work, your contribution should be the next bit on top of it, not redoing everything that somebody's already done. Yeah, well, it kind of makes your work pointless as well. Because it's like, wow, well done, you've just done something that somebody had already done for their work. Whereas instead you start from the cutting edge and then push the cutting edge a little bit further. Right, so in case you guys just missed that, I forgot my first rule of Fight Club and forgot to put the draw function. If you don't, just so you can see, if you don't put the draw function in, none of these actually do anything. So they're drawn, but they don't react. I'm not sure why that is. It's obviously something which yeah, pretty much. Internally somehow. So now these will work. Right, so anyway, we were getting on to, eventually, events and event handling. So as I said, everything in control P5 is handled within this control event. So I'm not going to type it out, it's going to take forever. We have control event, which is an event or method which gets called with a control event. And as I said earlier, each thing gets referred to by the name you give it. So here we've created a button called button1, we've created a color picker called picker1, and you'll see here, what is going on? You'll see here this control event C, if we call c.getName, it will return the name of whatever it is. So if it's button1, we're going to print a little message, button1 was clicked. If its name was picker1, we're going to say the picker1 value was, and C has these things, as like C can also hold some values. So if we actually just jump back to here, control event, you'll see when this control event gets passed in, it can have an array value, it can have the controller's name, it can have a string value if it's a text box. You know, these values will be filled in depending on what sort of control it is. So you usually want to check to see what it is you're doing before you try and get the value. So here you'll see we check if it's a button. If it's a button, we print out. And then if it's a picker, then we can access these array values. If you check them when it was a button, you'll probably find there's nothing in the array values. But now, when we run that, if you watch down in the little console window down here, push the button. Oops. Oh, really? Yeah, so button 1 was clicked when I click on that. And when I adjust this, picker 1 value is, and it's a floating point, so you'd want to round these to ints ideally, but 60, 255, 255. 60, 126, blah, blah, blah. As you can imagine now with these, we can grab these values immediately and start working with them. There is also, it's kind of neat, in addition to this one function which receives every event, each function actually has its own event to get fired. And these events are based on the name of the thing. So you'll see up here, and this is why it's sort of important to pick good names. So button1, picker1. I now have post these events. Void button1 will get called whenever button 1 is interacted with. Void picker 1 will get interacted whenever picker 1 is interacted with. So these values, as far as I can tell, always pass in an int. It might be different if it's a string, but certainly for the buttons and pickers, I haven't actually checked with text boxes. I might do that and report back tomorrow, I guess. But now you can see if I click on button 1, you'll see button 1 was clicked. So this is being called in this function, button 1 was clicked, and then control event button 1 is clicked.
Oh, okay, so it's called.
Yeah, so basically the method and control event gets called. So it doesn't override it, it just provides you a different way to handle it. And if I do the picker, this time for some reason they get called the other way around, so control event gets called first, and you'll see picker 1 value is this, and then this picker 1 function gets called. Now because this is an int, and this basically holds 4 values, so red, green, blue, and alpha, we basically have to use this red, green, blue, and alpha methods will return. It takes the int and it basically returns the sub-values. So if you try and print that int out, it will be wrong.
That's why it didn't have the red didn't have the one after.
Yeah, so it's basically a lower precision than this, so it's been rounded down. If we actually just try and print out, so let's just say here plus int, plus value. Now we do that. Click on that. So here you basically, for the control event, you get a separate floating, because we're calling get array value, we get a separate floating point for each number. In this one, it's actually just stored in a long precision, so there's less precision per thing, but that's okay. And by screwing with that, I have now made those values wrong, so don't touch the value.
Just asking if the printed screen.
Yeah, I guess in trying to format it, perhaps it's... Oh no, now it's not working at all. Or is it? Oh, that is. I don't know why it wasn't working first.
Well, that's 92, 194, and 192.
Okay, so there's obviously some rounding error in it. So depending on how precise you want it to be, you may be better off with the picker to actually use this one if you want a really accurate value. It's just, to be honest, I would probably write most of the code in this control event anyway, since that way it sort of makes it cleaner. But there is the option to go this way as well. In this case, obviously, it's not the best thing because the numbers aren't coming out completely accurate all the time. Right, so that's Control P5, a very brief example. But if we jump into here, as I said, when we install the library, we also get all the examples which come along with it. So if we go examples, that sounds like an interesting one. Oh, well, let's just open up one of these, right? It's hopeless. Tempted to plug my sticky mouse back in. So this is the accordion. So an accordion is just a collapsible thing. And each of these buttons. Yeah, but it's a collapsible list menu. So yeah, lots of things in there. What I might get you guys to do for next week, perhaps I'll leave it till tomorrow to issue it, but get you to sketch up a design on a piece of paper and then get you to build it using Control P5. Me.
So the assignment, are we going to show it to you?
Which one? Mark's one? Yeah, so Mark is going to be coming in for the first 30 minutes or so. 30 minutes to probably an hour. Probably not that long. So he'll be here for the first part, but I'll be teaching for most of the rest of this course.
He's going to take us through the topic, isn't he?
Oh, okay, well, I don't know. He's going to come in for some point tomorrow morning. He said he'll probably be maybe half the class. Yeah, but you're stuck with me for a while, sorry. So this is another one you can use. So this is Interfacia. I'm not going to go into too much detail about that, but it looks like that.
Oh,
So, yeah. Same thing. Yeah, and there'll be hundreds of different alternatives. You know, have a try them both, see what you like. But you know, this one I think is a little bit more sci-fi kind of cool. This just looks like that. But I mean, different strokes for different folks, depending on what you're trying to do as well. And there'll be heaps of other libraries out there that, you know, if you don't like either of these, feel free to have a search. There'll be likely hundreds of them. But yeah, it provides all the usual stuff, buttons, checkboxes, blah, blah, blah. I don't really want to get any more into that though. So that's Control P5 and Interfacia if you want to use them. But now let's get into graphics. Okay, I'm just having a look because there is a huge amount of stuff to cover on this. But I don't know if I want to cover it all in one go, because it's also pretty in-depth. So, yeah. So it's interesting, but it's hard work. And yeah, with this sort of stuff, like last year, this was actually one of the pushes for me to use open frameworks over processing, because open frameworks is built natively on OpenGL, whereas processing sort of kind of uses it, but in a weird kind of way and stuff. But maybe we'll do, what was it, 11? Maybe we'll do 30 minutes of it or so. So we'll have an hour and a half today and maybe an hour tomorrow. Try and get through it. So we're going to look at transformations, creating motion and animation, sort of. Not so much, but that's right. Motion animations and transformations which happen over time. Bitmaps and pixels and textures. Right, so processing the drawing canvas. So we haven't looked at this yet, but processing has multiple ways of doing rendering, and this will actually be interesting to go back to your example. No, Jonathan's. So which one was yours? It was, that one was the slow one, wasn't it? And currently that's doing 2,500. So I don't know whether this will make a difference or not, so I click. Okay, now it's just working. I don't know why it wasn't working before. Very true. So yeah, processing has multiple rendering modes. So there's the default renderer, which is what we've been using so far. There's P2D, which is built on OpenGL. There's P3D, which is built on OpenGL. And there's PDF, which is if you want to render it and you just get a PDF file out the other end. It's not particularly exciting. But we'll have a look at it anyway, because why not? So in order to use a non-default renderer, when you specify the size value, you can change it from, if you leave nothing, it uses the default. If you do P2D, it uses the 2D wraparound OpenGL, and if you use P3D, it uses the 3D wraparound OpenGL, and if you use PDF, it renders to a PDF. So if Jonathan has, which he has, we can change that from the default renderer to P2D. And yeah, so you see now it doesn't actually look quite as pretty. And the reason for that is the default renderer uses the Java rendering libraries which have anti-aliasing and all that sort of stuff on by default. The P2D is built on OpenGL. It doesn't have it on by default. You can enable it, but so it doesn't actually look as pretty, but now it's running in OpenGL, so theoretically it is potentially a little bit faster. The other one I thought, which might actually be good. Which one of these? One of these was Robin's. So potentially, do you have a size? Oh, yeah. So because this one's sort of a bit more animaty, it already runs pretty quick, to be honest. But let's see. See if it makes any difference. So you can see it's actually a little bit smoother. So the other one, you know, if you look how sort of smooth that's it's gone black. So yeah, it's quite a bit smoother than if I turn that off. You can see there's a little bit of maybe lag in there. It's just it's not a huge difference. It's probably the difference of a couple of frames per second. I'm pretty sure we can do P3D as well, and it's just going to run the same as P2D because it provides that functionality, but we're not using it. Possibly the other thing is you can sort of just make out here the stepping in the edge lines. When you run it on the default renderer, you won't get that because those will be nicely anti-aliased, but you know, whether that's important to you or not, gives you slightly crisper, cleaner edges, but then you can also see stepping. Yeah, so that's P23, P3D. There's a bit of an example. By default, render uses Java 2D libraries. When deciding which renderer to use, balancing number of factors, speed, accuracy, usefulness. Switching to P2D or P3D is advisable given one of the following scenarios. You're drawing in 3D, fair enough. You want your sketch to run faster, so with Robin's one, we saw a slight difference. If you'd been doing some more complicated stuff, it might have become more important. Or you're drawing in 2D but want to use a particular graphic effect not available in the default renderer, such as lighting, textures and lighting. Then it goes on to discuss a bit more about this sort of stuff, which I'm not going to bother going into. The only last thing, just for interest's sake and just because it's there, we will look at PDF rendering in case you ever want to do this for reasons unknown. Oh, well, there you go. So let's jump into, let's pick one. I'll just make a new one. Oh, no, there was one in there. I'm sure I had one open before I can do. So this, if we want to render to a PDF, we have to import processing.pdf. So if we go down to Sketch, import libraries and hit PDF, it'll give us that line of code anyway. Then in setup, we specify size, and as before when we did P2D, P3D, we do PDF. If we're doing PDF, we also have to include the name of the file we want to save the PDF to. Does this actually have... Right, so it does have a sketch folder. And this one, this is the example I got straight off here. So if you just, I might add a link, but otherwise if you just go to the processing thing and search PDF, it's the first one. Then you draw something and you exit when you're done. And this will finished, so nothing's happened. But if we now look into our processing folder, we have this PDF. And lo and behold, that's our processing sketch. So that one's pretty boring.
Is that do the aliasing thing as well? Just
yeah, I think so. So from my understanding, the way this works is it actually writes the... It's not actually just taking an image and then saving that into a PDF as like a PNG. I think it actually writes the PNG, the PDF code, because PDF has its own rasterizing or I guess scalable vector graphics thing in it. That's why you can put searchable text and graphics, which you can, scale indefinitely and they won't get pixelated. So I think processing will actually write the code. The other benefit of that is it also comes out as extremely small. So, regardless of what you're doing, it's probably going to come out at like a kilobyte or two, because it's actually basically telling the PDF file, like Adobe Reader, how to render it rather than saying, here's a picture, just draw that. Damn it. So here's another one which does multiple pages. So this one's going to render the first 100 frames.
So you use exit to close off the PDF?
Yep, exit will close off the PDF. There's also another way of doing it. Is that finished yet? I don't know that I actually ran that. So this one is rendering the first 100 pages, so you see 37 kilobytes. And all this one is doing is moving a line. So you see the animation has now been written over 100 pages of PDF, or 101 pages. Yeah, so you can basically make your own PDF flipbooks. You can do screen display as well. So if you want to display something on the screen, you can use begin record and end record, which basically will tell it. Oh, on this one they haven't actually specified PDF because we are also rendering to the window. So if you do PDF here, it won't draw anything on the window, but if we want to draw something on the window so we can see what it's going to look like, we can do begin record, PDF, file name PDF, and then end record when we're done. And that will draw something to the window and also save that to the PDF, and so on and so forth. So yeah, for Christoph's stuff. So have a look at the PDF thing on the processing website. It's got a few examples in there to do various stuff. It's quite cool. Yeah, images don't look great, mostly because of the difference of expectations in how PDF should look, scalable and high res versus what happens when image data is written to it at 72 dpi. So obviously there are restrictions in the PDF format. Yeah. Create font. So yeah, text is no longer treated as shape data, and so it's treated as text. So if you do a certain font that the person doesn't have installed on their machine, you have to include that. And yeah, some other bits and pieces. Again, exit is really important when using PDF with size. So that would have been where you went wrong. You basically weren't telling it when to finish, because if you do size PDF, you have to call exit to let it know that you've finished writing to the PDF, so it save the PDF and be done with it. Otherwise, you can use begin record and end record. Right. Okay. So P3D, and in fact, we don't even have to use P3D for some of the stuff, because some of it can be covered in the default one, and I think if it encounters stuff it can't cover in the default one, it gives you a warning anyway. So if I try and do something like, let's get rid of this PDF stuff. Let's say I want to do a translate like that. Translate, or this particular variation of it is not available with this renderer, so we try and do it with the default thing, and it's going to complain because this one doesn't handle 3D. Does it handle 2D? So it handles 2D. The default renderer will handle the translate function in 2D. And same thing here. If I do P2D here, it will say translate with X, Y, and Z coordinates can only be used with a renderer that supports 3D, such as P3D or OpenGL. So we're not going to look at using just plain OpenGL, although it is possible. But P3D is built on top of it anyway. So if I run that now, it will quite happily translate things to 1 in the X dimension, 2 in the Y dimension, 3 in the Z dimension. Yeah, so who here has used OpenGL, written any code in OpenGL? Yep. Okay, and I guess you've done it fairly recently. Yeah, so yeah, OpenGL has various functions to translate. So translate is used to translate an object. So you have translate in the X position, and this is typically the way the coordinate system is. So if I'm facing you guys, this will be negative X, this will be positive X, Y is traditionally positive and negative, and Z is positive and negative in that dimension. But I mean, you can set up your axes whatever way you want, but traditionally that's the way you do it. So X is the horizontal plane, Y is the vertical plane, and Z is the depth plane. And the way it works is, say we do, and scale works the same way. So if we scale along X, we're scaling this way, and then rotating, you basically rotate through that dimension. So if we think of X moving along a line running from left to right, a rotation through X will rotate it through that axis. So if you imagine you attach a piece of something to the end of it and spun it around that's what you'd end up doing. So these effects are, what's the word I'm looking for here? Accumulative. So if I translate something, move it this way, and then, so if I call translate, it'll move this way. If I call rotate, then it will rotate around that point, or potentially around the origin point. So it's not like you call translate and then rotate will just rotate it from a different point. Like, they all add together. So one thing which will potentially save your life when writing OpenGL code is these things, push matrix and pop matrix. So we're going to see an example of this later on, but say you want to draw multiple copies of the same object, and your object is made up of various things stuck together. So basically what you can do is say, this is what one thing looks like stuck together, and put that in a push matrix, pop matrix. So say this is our origin, and then we translate across and we rotate so that that's attached to it like that. We can have that encapsulated within a push matrix, pop matrix, and then we can just go, okay, translate this much, and then print it or draw it, and that'll draw the drawing, push it, and then pop it, and then you say, okay, now translate this far and push pop. And rather than, it going out here and then it draws this one, translates, rotates this one, then you say, okay, translate, and now it rotates it up here. And we'll see some effects of that later on, but it gets pretty confusing. So push matrix and pop matrix, I'd highly recommend adopting them and using them all the time. Yeah, so let's have a look at some example code. So this one is actually just using the default renderer because it's only working in 2D. But you'll see in here we have some stuff, X, Y, angle 1, angle 2, seg length. We set it up to be a certain size, turn on smoothing, stroke weight, blah, 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 blah. You see here we've got our push matrix and pop matrix. So basically push matrix says, okay, store the current state of the world, and then we draw some stuff, and then we pop matrix. We return to what that state was. And you can do this multiple times. So you can go push matrix, push matrix, push matrix, push matrix, and then you pop them off and you return to the most recent one you pushed. And then we have segment. In this segment, it translates by an X and Y position, rotates by an A, and draws a line. And these angles are dealt with by mouse X and Y. So let's run this and see what it looks like. So as I move my X position, you'll see we're basically hinging around this point here. As I move my X, it rotates this outer limb, and as I move my Y position, the inner one, and this one rotates the outer one. So we end up with this kind of weird robot arm thing, which is dangling from that position. Now, as I said before, these things are cumulative. So you'll notice here we basically push and rotate. If I comment this one out just to start with, so we're just drawing the first one. So here is our little rotatey thing, and it rotates around. And let's just say if I remove that one and just do the second one now, you'll notice that it doesn't swing back and forward. And the reason for that is it's basically getting this translate and rotate. It's inheriting it from its parent. So its parent is translated and rotated, and then it's translated and rotated as part of the chain down there. So if I put that all in, and yep. So if we look at that, we go through and we translate. So we have this angle 1 here, which is basically treated by rotating or moving the mouse from left to right, mouse X. And we translate by X and Y and rotate by A, so that basically rotates the first one. And then the second one we do angle 2, which is the Y, and we push it out by the length of the segment. So, we draw this one, and then we essentially translate out to the end of that, and then draw the second one, but it inherits the position. So is everyone sort of following this? It's kind of a little bit hard to get your head around, but... What's that? Okay, so you've had a little bit of practice with it.
I had tons of experience with that.
Yeah, it's one of the, and I mean this is only 2D as well. Once you get into 3D, it gets even worse. But yeah, I mean, basically the thing to think about is they're cumulative. So any translation, rotation, scaling, whatever you do, is going to affect everything which comes after it, unless you use push matrix and pop matrix, in which case you can sort of segment them off. And it doesn't matter. You can see here, translate, rotate, and line, or translate and rotate rather, are in a different method. It doesn't matter where it is in the code. Everything just adds up and stacks on one after the other. So make sure you use push matrix and pop matrix if you don't want objects to be connected to each other.
So if they were not, if we didn't use push matrix and the pop matrix, what will have happened in this case?
So in this case, because every time it draws, we'll probably see, I don't know, in this case it's actually obviously resetting it every time it calls the draw method. It'd actually be interesting to see if that's true, and let's try that. Okay, so in this case, obviously when draw gets called, it resets the matrices, so it's not such a bad thing. But let's say we want to do, we want 2 swinging arms now. And let's just do a translate by 50. And I'm going to put that back to the default renderer. So you saw there lines in the OpenGL renderer are squares. Lines in the default renderer are nicely rounded. So, you know, it's just how it is. So now you see we've got 2 of these and they're translated by 50 units to the left. So if I get rid of the push matrix and pop matrix in here now, might make that a little bit bigger so we can see what's going on. So now you'll see it's essentially been attached to it. So all the rotation and translation are also affecting the next one. So yeah, objects which shouldn't be attached to each other, you should have push and pop matrices around, or push and pop matrix calls around them to make sure they're separate. Otherwise, OpenGL will just keep on stringing them along. And as Jonathan was saying, it's because essentially it affects the local transform, or the world transforms, so that everything keeps jutting along. So yeah, as I said, put these back in here, and now they're essentially disconnected. Now we have the start of a spider or something. Those little wobbly legs.
If you use 3D models, you have to look into where they place the origin point. Sometimes I've had models where the origin point is here, even though the model is there, and then there's this weird rotation.
Yeah, so we'll look at that. We're getting towards rotation in particular is particularly hard because there's 2 sorts of rotation. So if I say let's rotate this object around its y-axis, we're going to rotate it on that point. But then if I so they're the same thing. They're just called rotate around x, y, and z. But let's say, let me attach this to something on the board. So let's attach this to the dot of the eye. So if I rotate around this object's y-axis and the origin is here, it'll rotate like that. But if the origin is actually here, it'll rotate like that, which actually gives you quite a different sort of impression. And worse still, as Jonathan was saying, if the origin of this is over here, it will now rotate like that.
A lot of people line it up to the model and have it centered perfect, even though then the origin point is off to the left and you rotate it and weird things happen.
And it gets especially complicated when, say, that again, this is the origin point, and we want to have, if we want to have an object which is rotated and then translated. Like, so if we have, let's say we have a rotate by 30 degrees and a translate, and I'm getting way ahead of myself, but we are going to look at this. If we have a rotate and a translate, if we do it one way, it'll rotate like that and then translate like that. If we do it the other way, it'll do the translation first and then the rotation. So you end up, one of them you end up with your object here, the other one you end up with your object here. So it starts getting quite complicated pretty quickly.
Photoshop's interesting. It sounds like Photoshop's transformation commands.
Yeah, well, it'll be based on exactly the same thing. So it's 2D or 3D geometry, and it all basically works under the same system.
If you do like certain models, you'd have to have the origin state to the ground though, take into account. Like if you're doing trees, for example, you want the origin at the bottom, not in the middle of the tree, otherwise you have the trees on the ground.
Yeah.
Then you take that into account for rotations.
Yeah, we will look at one 3D model loading thing in here, but you know, 3D model loading or using 3D models sort of always brings up the thing, because as Jonathan was saying, you know, if it's a tree, you probably want the origin at the bottom, but then if you rotate the tree, it's going to be rotating like that. Whereas if you want to rotate the tree around its axis, you know, you're going to have to, essentially what you actually have to do, if the point is here and you want to rotate around its axis rather than like that, you have to move the tree down, rotate it, and then move the tree back up again.
Photoshop just center point.
Yeah, well, that's what's happening behind the scenes. Photoshop is just making it easy for you. So moving the center point is essentially this thing of translating it down and then translating it back up again. Photoshop's just doing, that's what's happening behind the scenes when it's doing that. Right. So we'll do a few more minutes of this. There's 2 options if you want to do 3D graphics in processing. You can use a P3D library, which is built on top of OpenGL, makes things nice and tidy, or you can actually use OpenGL itself. We're not going to talk about using OpenGL itself, because P3D provides pretty much most of the functionality you want. We'll look at OpenGL when we get to frameworks, so don't worry about it too much. P3D is integrated directly into processing. It's lightweight, and you can enable it using size X, size Y P3D. OpenGL provides full graphics support. So P3D is a subset of OpenGL, so it doesn't have everything you could possibly ever need, but it's probably got as much as I've probably used in my life. So, you know, if you're doing really, really fancy things, you might need to go to OpenGL, but I'd say for most things, P3D is probably sufficient. So we're just going to focus on P3D. So we have this scene here. And I used the copy to HTML thing to get the syntax highlighting in there. It's quite neat. So if I run this, there we go. We have a cube and a sphere. Very exciting. And all with just 1, 2, 3, 4, 5. Oh, there you go. It says at the bottom. 16 lines of code. So set up the image size, set the background to black, turn on lights, because if we leave this one off and run this again, when we look at our cube, there is, like, if we look at this image here and then look at our cube, there's no shadows on the side. So we turn on lights to make sure that we get shadows. So now let's split this up like that. So this draws our box, funnily enough, because it says box. So we have no stroke. If we turn no stroke off, probably not actually, or we may not actually be able to see it, but, oh no, there you go. So it now has sort of lines drawn around the outside. So we translate that to 130 by height divided by 2, rotate it by 1.25 in the y dimension by that, rotate in the x dimension by that, and draw the box. And then pop matrix. So you see here, push matrix and pop matrix. We don't want the two things to be a lot like relative to each other's rotation, so we push and pop. Then the sphere, we turn fill off. So if we comment that out, we get a filled sphere. And again, you can see the overlying stuff on it. But it's kind of more interesting if we do it this way. Turns the stroke color to white. So that's basically the color that these lines are drawn on. Translates that across and then just draws an enormous sphere. So there you go. It's just that easy to do 3D graphics.
So how do you know the center in this case of, so for example, if you're rotating it, how does it know?
The origin point
the origin
default
point
is always in the center of the line.
Oh, okay.
Yeah.
Yeah, it's only in 3D programs that you generally try and specify a move.
Yeah. So with, I'm pretty sure that's correct anyway. With these primitives, so box and sphere, the origin will always be in the center of it. Right, so everyone understand that code? Hopefully. It's pretty straightforward.
That makes me appreciate Blender and 3D modeling.
Yeah, 3D modeling makes life a lot easier. So the next thing we can do is we can define our own shape. So it's all well and good to draw boxes and spheres, but let's say you want to do something a bit more complicated. Well, you can define a shape yourself. So basically you do that by saying begin shape and what sort of shape you want. So quads are, imagine making stuff out of post-it notes. Oh, I think there's some here. So imagine making something out of post-it notes. So say you wanted to create a sphere, you could do quads and just put them together like that. And basically you define the four corners of each quad. And so it'll take, you see down here we have vertex. Once again, I'm getting ahead of myself, but you basically use vertex to define the 3D position. So if we say quads, we'd say this is, let's say 0, 0, 1, 0, 1, 2, 0, 2. So
You showed a picture of the sphere. So
each of these points is a vertex. Is that what you're going to suggest, or yeah?
So like each four points that you see.
Oh yeah, good point. So yeah, each of these intersections here is a vertex which has been defined, and I mean I don't know. I'm sure they do it mathematically, so you can dynamically resize a sphere, but you could theoretically create a sphere by saying, okay, put a vertex here, 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 and here, and each of these, I can't actually tell because there's so many lines on there, whether it is quads. It looks like it might be, otherwise it could be triangles or something, but you define this point here, 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 here, and so on, and you could build up your sphere out of lots of little quads. A quad strip is kind of the same, actually. Yes, we get a little bit ahead, but basically, so this is actually OpenGL. I'm not sure how many of these processing support, but this is a triangle strip, but a quad strip is the same idea. So if you do triangles, you have to define each one. So you go like 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, sort of thing. If you use these strips, though, it basically uses the last point or so. So a triangle strip, we go A, B, C. And then when we put in D, it'll create a triangle out of BCD. We put in E, it'll be CDE. Put in F, it'll be DEF. So that's a strip. So in a quad, it's obviously the same thing. So we go A, B, C, D. And then we go E and F. And it'll go C, D, E, F. And then we go G, H. And it'll go D, whatever we were up to. So basically, it takes the last 2 points and the new 2 points to create a new quad. That's a quad strip. I'm not going to deal with triangle fans at the moment. I'll come back to that. Oh, God, I have to. Okay, triangle fans. So triangle fans is a different way. Let's say you want to create something which sort of orbits around a center point. A triangle fan, our first point we define is the anchor point. And then every 2 points around that, we create a new one. So we say A is our anchor point. Can you guys all see that? A is our anchor point, and then we say B and C, and it'll create a triangle. And then when we add D, it'll go C, A, C, and D. We go E, it'll go A, D, and E. F, it'll go A, E, and F. So depending on what you want to do, if you want to do long snakes, use a strip. If you want to do things which sort of come out of a point, use a fan. There are reasons why you'd use one over the other, but I'm not going to deal with that at the moment. Anyway. So that's shapes. So quads, quad strips, triangle fans. I'm sure there are other ones as well, and they might include these ones, points, lines, line loops, etc., etc. I haven't actually looked into how many processing supports, but yeah. Begin shape, throw some vertices in, end shape when we're done. So begin shape quads, and this is basically telling it what color that point should use. So that's like yellow, that's white, that's cyan, that's white, that's yellow, that's blue, or something to that extent. And then these are the positions of the vertices on each of these. So let us draw our very own shape. Right, so set up our window with P3D. Background is white, translate to the middle of the screen, set stroke on, and rotate it a little bit. So we're using radians as coordinates. So pi is a full rotation in radians from memory. So half pi would be a half rotation. Negative pi over 6 would be a third of a rotation, full rotation. No fill, so we're turning off fill, so we just want to draw these lines. Now we basically define. This is done begin shape without anything in it, which I guess defaults to triangle. Oh no, must default to line. We'll figure out what it defaults to in a minute. So anyway, this code draws that. Yeah, let's find out, shall we? The easiest way to find out. Is to comment out most of it and see what we get. Nothing. For a line, you shouldn't. Oops, wrong way. Odd. Nope. Yeah. Yeah, that is strange. So I'm guessing it's lines. I'm not quite sure why that first line didn't show up, though.
Probably, yeah. I don't know that it's doing a triangle, but it's just not causing that. That's what I get to.
So what are you talking about? Like doing...
Like it uses if you use the first three vertices.
Oh, okay, yeah, that might be a good point actually. So it might be defaulting to a triangle, and we just can't see the last line.
You're only connecting like 1 to 2, then 2 to 3, but you're not connecting 3 back to 1.
Typically with a triangle, though, you don't have to. If it's a triangle, it will just do it automatically. So let's see where that fourth one goes. Nowhere. All right, so it really helps if when you're doing begin shape, you specify what sort of shape you're doing. I guess probably the easiest. So if we do quads now, we'll still end up with that shape for some reason. Oops. Oh my God. I do not know why. Let's have a look at the documentation. Begin shape.
Maybe it's putting lines. The 2 vertices.
Okay, so begin shape. Begin shape begins recording vertices for a shape, and end shape starts recording value of the kind. No more points. Ah, there we go. So with no mode specified, the shape can be any irregular polygon. So you can just draw as many lines as you want, and it will keep attempting to fill them in. If you specify, if you do this, it will just draw whatever shape you want. So internally, I'm guessing that probably breaks it into triangles or quads or whatever, but I've tried to make it a bit easier, but for somebody who comes from an OpenGL background, it just makes things more confusing. Yeah, so if you don't specify anything at all, it will take all of these things and join them together. So basically, it'll be drawing. If I haven't actually looked at drawing this out myself, but I'm guessing it starts from there and sort of goes down, across and up and down and across and up and down and across and up and something like that. Anyway, so it's drawing it as a polyhedron, just going on.
So when connect the first 2 lines, does it actually need to form a mesh?
Yeah, I guess.
There's only 2 lines on the second.
I don't know. I'm not 100% sure. Yeah, it is. It's weird.
Sorry, I've got a question around. If you go back to the sample, like you've got minus there. I thought, for example, if you're dealing with coordinates, like you start from 0, 0. So how is it like going back relative to where it was before?
Yeah. So you see up here, we've translated it by width -2, height -2. So everything is now from halfway in the image. So if we hadn't have done that, you'll probably find it's half of it's hanging off the image.
Yeah.
But because we've translated it into the middle, this is now 0. So negative is just traveling in this direction. And in fact, like even at 0, negative is in this direction, so it's off the side of the screen. But if we translate it here, negative will just move it left of wherever we are. Yeah, we're just shifting the origin essentially. And I'm just going to do a couple more slides before I stop.
Like in 3ds Max and stuff, you can create your model and then export it out from that where vertex format.
Yeah, so various ones will do it. So let's look at one which possibly will be a little bit easier to understand. I can't remember. So I've included things for where these are. So if we go to topics, geometry, RGB cube, and if we run this one, so this one gives us a nice filled RGB cube which follows the mouse pointer. And if we have a look at this, please, dear God. Begin quads, hooray! So that's all right. We know what this one is trying to draw. This one is drawing quads. So you see here, there should be 1, 2, 3, 4, 5, 6, and no more. Because a cube has 6 sides, and there are 6 quads drawn on there. So that's all right. Maybe I should have just skipped the other demo and just started with this one. So yeah, we're basically drawing 6 quads. So 1, 2, 3, 4, 5, 6. And we can specify each of their colors. And the way OpenGL works is it blends between colors in a polygon like this. So you see, here we're setting it to, I don't know, cyan, white, yellow, and blue. And if we run this, hopefully maybe we'll find, or we can figure out.
Oh, so you're actually setting the each vertex color.
Yeah. So I think that might actually be that side there we're looking at. So you'll see here, this one I think is cyan, which will be that corner there. This one is white, which will be that corner there. This one is magenta, which will be that corner there. And that one is blue, which is that corner there. So this bit of code is drawing this side of the cube. Obviously it's sort of going backwards around here, but that's because we're rotating the cube as we go. So the order that they're drawn is going to get not match up. It's not necessarily going to go clockwise when we look at it because we've actually rotated the cube around in order to see that side. But let's try and do another one. So this is white. What's that? That'll be yellow, I think. It's white, yellow, red, and purple. So white, yellow, that one there. So white, yellow, red, and purple. Although it looks kind of orange. It does look red on the screen. But you can see we're getting this nice blending effect between them all as well. And if you keep going through them and figuring out what colors are what, you'll see them. One thing to note, OpenGL uses 0 to normalized coordinates for colors. So 0 to 255 becomes 0 to 1. So 255 is 1. 128 is 0.5, so on and so forth. That's just the way the OpenGL people chose to do it, and we're not going to argue with them. So yeah, that shows us vertices and vertex fills and vertex demo. Why did I not link to that one? And this one, I think, is the bottom one. Yeah, so this is showing us a quad strip. So for this cylinder, this is a quad strip. So I'll see if I can get it in a way that the lighting shows. So each of these is, we have 1, 2, 3, 4 points, and it'll basically be going like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And as I said before, it uses the last 2 points. So if we define these 2 and then define these 2, it'll create a new quad out of that. Then define these 2, it'll create a new quad out of that, and so on and so forth. So that is that. And then down here we have a triangle fan, which will be giving us this little circle on top. So there'll be a point in the middle which is defined, and then there'll be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, however many. I suppose you could just count how many points are there. But that triangle fan is being used to draw there. So we've got 2 of the things we looked at before. We got quad strips being used to draw the sides. So as I said, if there's anything like long and snaky, strips are usually good. And if there's anything which sort of fans out from a point, fans are usually good. So we use a triangle fan to draw the little circle on the top. And
so are they actually, you create the fan at the top and then from the edges of the fan you then do the quad strip?
So they will be done in 2 separate pieces. So, or I would imagine so, that would be the sensible way of doing it. So if I get rid of this, keeping in mind that I haven't actually looked too closely at this code. Sort of, I think there's something on the bottom as well, which is why we can't see blackness. Let me just get rid of the bottom as well. Make it a bit more obvious. So now we have a tube. So essentially, that quad strip is being drawn with all of those points, and then we're drawing a whole separate object for the top. And in fact, if I then go and get rid of this one and draw this one instead, you'll see now we'll just get a little disk floating in space. There it is. So they're essentially completely different objects. They have no relation to each other. And you'd like to hope that perhaps, okay, in here, oh, in shape. All right. So yeah, because everything's relative to each other, they're all running under the same push matrix, pop matrix thing. So that's RGB cubes, and so that basically shows you how to do vertices, quads, make it nice and colored. This one is showing us how quad strips work, how triangle fans work, and we've already looked at this briefly, but actually I might just, what was it, processing, has all these things as well. So you see points, so you can see if we define these 4 vertices, we get 4 points, 1, 2, 3, 4. Lines does with pairs, so it'll take the first 2 and draw a line, take the second 2 and draw a line. Begin shape is something you don't normally see in OpenGL, but obviously it's trying to do its best anyway, so it's drawing them all together. This is also, okay, so if we put close at the end, it tries to close our object. If we don't put close at the end, it doesn't try to close the object. I didn't cover these because these aren't present in OpenGL, but obviously they are there in processing, or P3D, I guess. So, but anyway, the ones which are in common are points and lines. Then we have triangles, a triangle strip. So triangles we define, if we put in 6 points, we're going to get 2 triangles. Triangle strip we put in 7 points, I guess, but we're going to define this triangle and then that point and that point and that point, and we'll just keep joining them together. Triangle fan, we define our center point and then the points which orbit around it. Quads, if we have 8 points, it'll give us 2 separate quads. A quad strip will connect them all together. And this is another quirk of P3D, which allows you to draw non-regular polygons just by putting in a bunch of points, which is actually quite useful to know. It just confused the hell out of me because I didn't realize that it would do that. But yeah, so that's there, and I think that's probably enough for today. What's our next slide? Yeah, transformations. Yep, so that'll do for today. Anyone have any questions?
Oh, it's cool.
We are a third the way through today's lecture slides, so we're going to have to blast through tomorrow. But that's okay. Because we're spending more time on graphics and processing, we can pretty much just look at the equivalents when we get to them that in open frameworks. So we should be all right. Yeah, otherwise I'll stop that there. That's all right. And yeah, so Mark will be in tomorrow morning.
Okay.